Okay, the goal here is to change this system of equations into a matrix. The more equations you have and the more variables you have, the bigger your matrix is going to be. So right here you see we have two equations and two variables. So usually that's going to transform into a 2 by 3 matrix. So the first thing you would do is start by drawing your large square brackets on the outside, maybe something like this. Then you would want to change all of the coefficients into the matrix, leave out the variables, and make sure you keep the order. The x's need to all stay in a row right here, the y's need to all stay in a row right here, and the constants need to all stay in a row right here. This right here is going to be equation 1, and this is going to be equation 2. Usually, you won't take the time to write things out on the side and on the top for the rows and the columns. I'm just showing you here to teach you. So, since there's no coefficient in front of x, we just assume that's a 1. The coefficient in front of y is 3, and the constant is 10. Down here, our coefficient of x is negative 2. Our coefficient of y is 10, and our constant is negative 6. Sometimes you'll see a dashed line to separate the coefficients from the constants, but it's not necessary. A lot of times you'll just see it all together. Okay, so that would be the answer for number, this one right here. Take square brackets, 1, 3, 10, negative 2, 10, and 6. But this is a 2 by 3 system, so normally you would just work this out without a matrix. Matrices are more helpful for larger systems like this, okay? This is what we've been working on in class for the last couple of weeks, and you can see how time-consuming it is to work these out by hand. So matrices allow us to do it faster. They allow us to use calculators and computers and stuff like that to simplify the process. But first, you have to know how to change it into a matrix. So let's do this 3-variable system into a matrix. So let's start by drawing our brackets. Okay, notice I had made it a little bit larger because this one is a larger system. Okay, I could label my equation 1, 2, and 3. So let's go ahead and say that's equation 1, equation 2, and equation 3. And then at the top, you're going to have your x's, your y's, your z's, and your constants. Okay, so x, 2, 3, 10, and 11. Okay, 2, 3, 10, 11. Okay, down here we're going to say 4, 11. And here's the important part. Do you see how there's not a z variable in this one? That means it's missing, so we put a 0 to hold its place. Okay? Then we're going to put 12 right here. Alright, so we've done the first 2 equations. The last one. Equation 3 has a coefficient in front of x of 6, 12, and once again z is missing. And the constant is negative 3. So that's the matrix for this system. 2, 3, 10, 11, 4, 11, 12, the 0, negative 6, 12, 0, negative 3. Hope that helps.